So here we need to find the equation of the plane passing through the line of intersection of these two planes, and which is parallel to the x-axis. So two planes are given, which are pi1 and pi2. So the plane pi3 is also passing through the line of intersection of these two planes, pi1 and pi2. The equation of pi1 is given as r vector dot I cap plus j cap plus k cap, that is equal to 1. And the equation of the plane pi2 is given as r vector dot 2 I cap plus 3j cap minus k cap plus 4, that is equal to 0. And the equation of the plane pi3 will pass through the line of intersection of these two planes, pi1 and pi2. And this plane is parallel, plane pi3 should be parallel to the x-axis. It means that the normal vector n3 to the plane pi3 should be perpendicular to the x-axis. So now the direction ratios, so it means we can tell that n3 vector is actually parallel to, means it is perpendicular to I cap. So we can tell n3 vector dot I cap, that should be equal to 0. So now therefore the equation of the plane pi3 that passes through the line of intersection of pi1 and pi2, line of intersection of the planes pi1 and pi2 is given as, which is r vector dot, which is I cap plus j cap plus k cap plus lambda into 2 I cap plus 3j cap minus k cap. So that would be equal to 1 minus 4 lambda. And so therefore, this we can write it as r vector dot, so it's 1 plus 2 lambda I cap plus 1 plus 3 lambda j cap plus 1 minus lambda k cap, that is equal to 1 minus 4 lambda. So therefore, the unit vector, so the normal vector n3 to the plane pi3, that is given as 1 plus 2 lambda I cap plus 1 plus 3 lambda j cap, then plus 1 minus lambda k cap. And n3 vector dot I cap, that should be equal to 0, since the plane pi3 is parallel to the x-axis. It's parallel to the x-axis, so its normal vector is perpendicular to the x-axis. Therefore, we can tell 1 plus 2 lambda, that is equal to 0. So we can tell 2 lambda, that is equal to minus 1. So lambda equal to minus 1 by 2. Therefore, the value of, so if we put lambda equal to minus 1 by 2, then the value of 1 plus 2 lambda will be 1 plus 2 into minus 1 by 2. So that is 1 minus 1, which is 0. And then 1 plus 3 lambda, so that will be 1 plus 3 into minus 1 by 2. So that is 1 minus 3 by 2. So that will be minus 1 by 2. And then the value of 1 minus lambda, that will be equal to 1 plus 1 by 2, that is equal to 3 by 2. So therefore, n3 vector we can tell that is equal to 0 I cap minus 1 by 2 j cap, then plus 3 by 2 k cap. And the value of 1 minus 4 lambda will be 1 minus 4 into minus 1 by 2. So that is 1 plus 4 by 2. So 2 to the 4, so that is 3. Then, so therefore, the required equation of the plane, will be r vector dot n3, that is minus 1 by 2 j cap plus 3 by 2 k cap. Then that is equal to 1 minus 4 lambda, that is equal to 3. So this we can write it as r vector dot minus j cap plus 3 k cap, that is equal to 3 into 2, that is 6. So this is the, or we can write it as r vector dot j cap minus 3 k cap plus 6, that is equal to 0. So this is the required vector equation of the plane. And if we want the Cartesian form, that would be y minus 3z plus 6, that is equal to 0. This is the required Cartesian form, and this is Cartesian equation of the plane, and this is the required vector equation of the plane. So this is the final answer. Thank you.